Okay, ladies and gentlemen, let's bring your attention back up. We're going to hear from the genetic engineering. We're going to hear from the genetic engineering group. We're going to start with the concept. Please give them a warm welcome.
Well, hello, my name is Erica Croft. These are my partners, Noah McGee and Grayson Wood, and we are going to speak to you about the concept of genetic engineering. Genetic engineering, which can also be known as genetic manipulation, genetic modification, or genetic enhancement, is the act of editing the genetic makeup of an organism. This technology has been used by the human race for over 30,000 years, but its breakthrough came in the early 1970s, when E. coli became the first genetically modified organism. At the Asilomar Conference of 1975, the first regulations regarding code of conduct, experimentation, and regulating containment were made. But given that this was done over 40 years ago, the World Health Organization sees a need to update these regulations. Before this is done, the potential risks of this technology need to be taken into account.
Hi, I'm Katie Coleman.
I'm David Tomabad.
I'm Connor, and we'll be presenting on the pros of genetic engineering.
In 1973, Herbert Boyer and Stanley Cohen invented the first genetic engineering company. And they also invented the first recombinant DNA. And then in 1986, the first field test of genetically modified crops were in Belgium. There are many benefits to genetic engineering, such as animals will grow bigger, plants will be more resistant, and humans will not carry hereditary diseases.
When you genetically modify something, you're taking the genes from one organism and inserting them into another. These genes code for proteins, and proteins are the things that cause allergies to people. And so when you genetically modify something, you run the risk of introducing a new allergen into that organism. In 1996, the University of Nebraska at Lincoln ran a study where they used blood samples from 9 people known to be allergic to Brazil nuts, and they tested the reactivity to this type of soybean that had been modified to include methane, a protein found in Brazil nuts. They found that 8 of the 9 blood samples reacted to this type of modified soybean, and despite the fact that it was originally intended to be feed for cattle, it had to be completely taken off the market because of fears that it would enter the food supply. In a separate case in 2000, a brand of genetically modified corn known as Starling was accidentally used to make taco shells for Taco Bell. A woman in California claimed that the corn in the taco shells had caused her to have an allergic reaction. Although her claims are never proven to be entirely true, it did spark national conversation about the safety of genetically modified organisms.
Genetically modifying animals can provide bountiful harvested benefits. We just have to utilize them. For example, are the farm salmon and the GM salmon shown above. Now, the farm salmon grew to the above shown weight and length in a period of 18 months. In the same 18 months, the GM salmon grew twice the length and almost 3 times the weight. This would allow for a more readily available source of food for communities that need it. And another example of genetic engineering and its benefits is with chickens. They've been modified to where the avian bird cannot be passed on to other birds in the surrounding environment. This would help with farmers so that they would not have to worry about passing on food to other. This would help farmers because they wouldn't have to worry about damaging the surrounding ecosystem. Another example is in much needed communities in Africa fighting malaria. Mosquitoes have been modified to where they don't pass on the virus to their offspring. This would help many communities in Africa dealing with the large, widespread problem of malaria.
Let's talk about superweeds. Superweeds are weeds that have evolved to resist herbicides. These occur because of crossbreeding between genetically modified crops and unmodified weeds. This creates an unintentional consequence of superweeds, which contain a gene that makes them more resistant to certain herbicides, including glyphosate. Superweeds reproduce very rapidly, and because of this, They compete with crops for nutrients in the soil, potentially devastating acres upon acres of farmland. The problem with superweeds is most profound in the southeastern United States. One factor in the increase of superweeds is that farmers who use traditional methods of removing weeds don't use as much herbicides as farmers who plant genetically modified crops. Another factor is some farmers refuse to use superweeds are a very controversial topic, and they can seriously harm crop outputs of all farms.
Genetically modified plants can be produced to where they're resistant to drought, frost, insects, and different types of viruses. They can also help the common human. In India, there is a disease called vitamin A deficiency where they do not get enough vitamin A, and they genetically modified rice to carry more vitamin A. And they, before they died or were permanently blind, they got their sight back. But then it got such a problem where it cost too much money. On average, vitamin A deficiency kills 2 million people a year and permanently blinds 500,000. So if we can catch this in the early stages, we might be able to help the people see again.
The genetic modification of human embryos is done using a method known as pre-implantation genetic diagnosis. This process, which is performed outside of the womb, is used to screen for genetic disorders that can potentially be healed. In the near future, parents may be able to screen for non-disorder related genetic traits and enhance their child's mental and physical capabilities. This may seem convenient, but there's a large possibility that there could be new problems that will arise when trying to single out one specific trait. For example, in the late 1990s, scientists from various colleges around the United States, such as Princeton and the University of California, found a gene that linked to memory. They enhanced this gene in mice, and they experienced increased levels of learning and memorization, but also increase in sensitivity to pain. The latter is definitely not a desirable trait to have. If the genetic modification of human embryos is successful, there are still many problems that can arise after birth, such as a lack of individuality and a sense of belittlement due to the reason for their enhanced abilities.
Genetically modifying humans is referred to as gene therapy. It can be used to fight hereditary diseases that are expressed in the genetic code. The process is as follows. A carrier, called a vector, is genetically engineered to carry a desired trait and then inserted into the cell through a multitude of ways. It can be given through injection, IV, or a sample of the patient's cells can be taken out and introduced to the cell and then reintroduced back into the body. This can help fight many hereditary diseases, but it is also being developed to fight diseases caused by genetic mutations, such as cancer.
Genetic engineering has its talents, such as the rise of unexpected allergens, superweeds, and damage done to human embryos. The World Health Organization needs to be informed of this topic and see the cons of what this could possibly do.
The World Health Organization should set restrictions on genetic engineering until research has been done into how to prevent crossbreeding to occur, how to prevent harmful foods from entering our own food supply, and how to single out specific genes in them.
In conclusion, genetic engineering has many pros and cons, but the pros outweigh the cons. For example, it can be used to fight hereditary diseases and cancer through the process of gene therapy. It can also be used to make more weather-resistant, pest-resistant, and pesticide-resistant crops. This would allow for many places to be able to get more food readily and easily. It also can help with modifying animals because they can grow faster and larger. And it would also help with another ultimate food source. In conclusion, we believe that the current regulations on genetic engineering are more than enough for scientists to go forward and continue to help much needed communities.
Ms. Knight?
Question, and it's okay if you, it's outside the scope of research, but you mentioned that when they increased memory, it also, did you say that it increased insensitivity to pain?
Increased
Sensitivity to pain, that's what I was wondering, because I wasn't sure. And so it would make people more, now, was there any, did you find anything in terms of applications where that would help with rare diseases where people didn't have the ability to sense pain?
I actually did not find anything on that, but I read over the synopsis of the whole experiment, and it basically said that the mice became more sensitive to pain, that they were able to memorize facts.
Any other questions? Very good. Thank you.